compare any two numbers, say A and B, we will say that A is greater than B. So this symbol right here that I circled, that is greater than, is true if A lies to the right of B on a standard horizontal number line, or A is above B on a vertical number line. So that's the inequality definition. And what I find with inequalities is what people have the most trouble with is that you don't know those symbols very well. And then to make it worse, some of your former teachers may have used the alligator method, which is very foreign to me. I cannot help you if you're talking to me about how the alligator eats the other thing, because it doesn't make sense to me. So I will try to put in what these symbols mean as we work through this. But what we're going to be looking at today is some graphing of inequalities and then some interval notation. And some of you have had experience with the interval notation, and some of you, this is going to be the first time ever that you've seen interval notation. So we wanted to take a day and give you some background information before we get into what we're going to be working with this week, later on this week, which is the domain and the range. But when we graph inequalities, you probably remember this, is that we use an open dot when the inequality is a greater than or less than. So there's no equals in that part. And then the next sentence, use a solid or a closed or a filled in dot when the symbol is greater than or equal to or less than or equal to. So to the far right here, we have that equal to, and that's when we fill in the dot. Some other information. When the inequality is greater than or less than, what we do when we're writing an interval notation, again, which might be new to you, is that we use parentheses on the constant number. And when we see parentheses in interval notation, it means that the number is not part of the solution. When the inequality is a greater than or equal to or less than or equal to, we use what are called square brackets. And when we see square brackets with interval notation, that means that the number is included in the solution. We could also have an interval that goes to negative infinity or to positive infinity. Whenever we have infinity, we always use parentheses. We never use square brackets with infinity. And finally here, interval notation always needs to be written from least to greatest. I'm sorry, I did not leave you enough space to fill that in. From the smallest number to the biggest number. Every single time. And what a primary focus is going to be today is we're going to be graphing on our number line, and then we're going to be writing this in interval notation. So for each of the following, graph the portion of the number line described by the inequality, then write the equivalent using interval notation. Well, the first one is x is greater than or equal to. In terms of the symbol that's written in between the x and the 4, I want to identify that. But what kind of dot are we going to have on the 4? An open circle or a solid circle? It's going to be solid. There's an equal in here, so it's going to be solid. And then we want everything that's greater than or equal to, so we're going to go this direction. And hopefully that's a familiar idea for you. It's the interval notation that may or may not be familiar to you. But what's going to happen on this one, in terms of writing it in interval notation, we started at 4. We're going to keep going forever and ever towards the right. That means that we're going to say that we're going to go to infinity. Remember that infinity always has a parenthesis. Because the 4 is filled in, or because it's greater than or equal to, we will have a square bracket around the 4. That's interval notation. Interval notation sometimes looks like an order pair. When we look at letter B, it says x is less than 5. If we know how to read it, I bet we know how to graph it. Are we going to have an open circle or a closed circle on 5? Open, no equals. So we're going to have an open circle and it's less than. So we're going this direction. And then we want to write it in interval notation. Well, when we read from left to right. So as we look at our graph here, it's pointing towards the left. That means that we're going to be going in the leftward direction forever and ever and ever and ever. In other words, if we ever stop, we're going to be stopping at negative infinity. And I didn't say that very well. We're going to be coming from negative infinity. When we get over here to 5, that's where we're going to stop. So the farthest left that we can go is to negative infinity. Infinity always has a parenthesis. Because 5 has an open circle, or because it's less than, not equal, 5 is also going to have a parenthesis. Parentheses means not included. Square brackets means is included. Letter C. Negative 4 is less than x is how that statement is read. But in this case here, what I recommend is that you rewrite it. And if we rewrite it, all that I'm going to do is I'm going to switch where x and 4, negative 4, are in a problem. But the symbol in the original problem is pointing towards the negative 4, so it still needs to point towards the negative 4. So in this case, then, in terms of reading it, in terms of what I'm going to graph, this is x is greater than negative 4. That's the symbol. Are we going to have an open circle or a closed circle on negative 4? It's going to be open because there's no equal. And we're going to go this direction, towards the right. Once we identify that, we're going to write this in interval notation. We start on our graph at negative 4. We're going to continue right forever and ever, so we're going to go towards infinity. Infinity always has a parenthesis. Negative 4 has an open circle, so it as well will have a parenthesis. It is not included in our solution there. Letter D. The original problem is read 6 is greater than or equal to x. But oftentimes when it's written in this format, students get confused, which is why I personally prefer to rewrite it. Once again, when we rewrite it, I'm going to switch places. The x and the 6 are going to switch places. But wherever the inequality is pointing, it's pointing towards the x. It still needs to point towards the x in the problem when you rewrite it. When we look at our rewritten form, this means less than or equal to. And once we get it in that format, it's probably easier for us to graph. Do we want to have a open circle or a closed circle on the 6? Closed. because there's an equals in this problem, and we're dealing with less than, so we're going towards the left. And once we get that in the problem here, then we want to put this into interval notation. Well, we're looking at where does the graph start, and we can't tell where it starts because it's going towards the left forever and ever and ever and ever, which is negative infinity. So that's where we're going to say the graph starts. It's going to finish at 6. That's the last value. And infinity or negative infinity always has a parentheses. Because our circle is filled in, because there's an equal in the problem, we are going to have a square bracket around the 6. So again, for some of you, that interval notation is new. I hope that you have a little bit better understanding of it. Because now we're going to be given the graph, and we want to write the inequality for the graph along with its interval notation. So now the graph is drawn in for us. As we take a look at this, what we see here is that we've got an x, and we've got a 5, and we're going towards the left. So our inequality here, we look down and we see that 5 is filled in. We're looking at values that are smaller than 5, so that's going to be a less than or equal to. And when we write this in interval notation, again, because our graph is pointing towards the left, the place that we would start on this graph, if we could see a starting point, is going to be negative infinity. It's going to continue on until we get to 5, and we're going to stop at 5. And whether it's positive infinity or negative infinity, infinity always has a parentheses. Our circle is filled in, so it's going to be a square bracket. When we look at letter B, our starting point on this graph is -1, and we're getting bigger on this one. So this is going to be x, and -1, because we're getting bigger, it's going to be a greater than, and there's not going to be an equals on this because it is an open circle. In interval notation, we're going to start at -1, we're going to continue on forever towards the right, which means infinity, and once again, infinity always has a parentheses. In this case, because our -1 is open, because there is no equals in the problem, -1 is also going to be a parentheses. Sometimes we're going to put 2 or more inequalities together and ask what x values make both of them true. It's called an AND kind of problem. There's other kinds of compound inequalities, compound meaning more than 1, but we're not going to be using those right now. So we're sticking to one kind, which will hopefully be nice for us in our understanding. But before I go, and I don't know that you need to write this down, but I want to write down how this is read if you're curious. And the way that it's read is -3 is less than or equal to x, which is less than or equal to 5. And I don't necessarily think that you need to write that down. But if you want to write something down, maybe a more concise way of saying it is that this means in the problem is that x is between -3 and, there's that and, 5. That's what it means. So how do we graph that? Well, we're going to go to -3. And we're going to put a filled in circle on -3 because it's -3 is less than or equal to. Then we're going to go to 5. And 5, it's less than or equal to, so it's going to be a filled in as well. And then we're going to fill in everything in between. Everything in between -3 and 5. In terms of interval notation, sometimes this looks even more like an ordered pair, but you want to go in numerical order. -3 is smaller than 5. They both endpoints have equals in them. Both of them are filled in circles, so they're both going to have square brackets on them. If we look at the next one, x is between -1 and 10. So we're going to go to -1. Are we going to have an open circle or a closed circle on -1? Well, it's -1 is less than or equal to. We're going to have a filled in circle. Then we're going to go to 10. It does not have an equals on it. So what we need then is we need everything in between. And then we're going to put it in interval notation. So when we write this, again, it could look like an ordered pair in interval notation, but it's going to start at -1, that's the smaller, to the bigger, which is 10. -1 has a filled in circle, so it's going to have a square bracket. 10 is an open circle, so it's going to have a parentheses. Letter C. -6 is less than x is less than 4. In other words, x is between -6 and 4. The nice thing on this one is that neither one of those values has an equal. So we're going to have an open circle on the -6. We're going to have an open circle on the 4, and we want everything in between. But once again, here's where it's really going to look like an ordered pair. -6 to 4, because both of those are open circles. There's no equals in the inequality. We're going to have parentheses. Letter D. -7 is less than x is less than or equal to 3. We're going to put values. We're going to put something on both -7, which in this case is going to be an open circle because there's no equals. Over here on the +3, we're going to put a filled in value, and then everything in between. Again, these are compound inequalities. There's more than one of them. But when we fill this interval notation, again, go in numerical order. Smallest value first, biggest value second. The smallest value has an open circle. That means parentheses. The biggest value has a filled in circle. That means a square bracket. Letter E. -infinity is less than x is less than infinity. In other words, x is in between -infinity and +infinity. Any thoughts on what we would do for our graph? Ryan? The graph's not very straight there, but it ends up to be the entire number line. And when we write our interval notation, it's negative infinity to positive infinity with parentheses. Infinity always has parentheses. As we finish. Again, here's the graph given to us. We need to put it in interval notation. So we've got our compound, but as we look, we've got negative 2 to the left and positive 7 to the right. Negative 2 is filled in, so it's going to have a square bracket. 7 is not filled in, it's going to have a parenthesis. Letter B. Find the values of our endpoints. In the second one, 1, 2, negative 3 is to the left. 2 is to the right. They're both open circles. When we have an open circle, we're going to have parentheses. That looks like an ordered pair. It is in interval notation. Letter C. To the left, we see 0. To the right, we see 3. At 0, our number line is filled in, which means we're going to have a bracket. The 3 is an open circle, which is going to have a parenthesis. And letter D. We have the entire number line filled in. And because the entire number line is filled in, we're going to go from negative infinity to positive infinity. Infinity always has parentheses.